Hang on a second. There I am. Hey, Randy here. Shall we make a game? Do you ever realize that you hate software and everyone who writes it? Anyway, let's write some software. Oh no. Hang on just a second. I've completely gone blank on everything I'm doing. Oh no. Anyway, yeah, there we go. That's a good start. Yeah, so last time we got the list of kind of like neighboring triangles in. Next up, we need to generate these lists. So that's basically a list of triangles. So that'll be in here. This is where we're generating our, this is where we're doing code gen to generate the file for the imported nav mesh. Let's go and rename this. Because I'm calling it navigation mesh everywhere. Calling it navigation mesh everywhere else. How many characters is that? 15. Okay. Let's just have it for the remainders. I bet they're all comments at this point. Yep, they are. So now we can safely use find replace. I will need to make a slight edit to the model because of course it's still called a nav mesh in Blender. Where is it? I know it's, oh, it's just hidden. Okay. And then we're just going to re-export it. And done. Okay. So let's run the make command and just see what happens. So the next thing we need to do is we actually need to, this will probably fail. Probably. Oh. Yeah, like I was saying, this will probably fail because we're not initializing the struct fully. Then again, it might just leave it null. Who can say? Man, my tracking is really screwed up at the minute. What the heck's going on? Oh well. Man, this build's taking a while, huh? Okay, so let's give me a sec. Just go look at something. It's still working? Yeah, it's still working. Okay, the tracking works, and as soon as I focus another application, it starts glitching out again. I don't know. Whatever. It was working up until a while ago, and now it's not, I guess. Welcome to software. It sucks. Okay, so we've got some stuff in here where we're, we're writing some stuff to the console. We no longer want that as it's for debugging. We've already imported the headers, so we can get rid of that. Okay, so next up, we want to write kind of the end of that and start of, right the end of the neighbors. We want to write the start of the actual triangles. Okay, that should be a good start, and then we're just going to use this in our initialization.struct. We're going to pass in 2 more arguments here, so we've got an extra copy of those, and then we actually need to generate the contents of this. Contents of this array. Okay, so we've got locations, that's easy enough to get. The normal, that's a bit more complex, and the edge normals. Now, thinking about it, a feature I'm going to need, and the fact this tracking isn't working is actually really annoying me. Why isn't that working? It's so weird. What happens if I keep it on the screen? Does it work then? If I put, like, say, down there? Yeah, I can see it's just not updating whenever I'm if it's not focused. Well, that's annoying. I bet that's a bug someone's fixed by now. Okay, so yeah, so let me just bring up Sprite and just kind of draw what I actually need to calculate here. Will Sprite work today, or is this software still sucky? Sprite works today. I didn't do anything different to last time. It's just this time it allows me to draw things. Okay, so we've got a nav mesh triangle like this, and we want to calculate the vector up here. So we can do that by calculating like the vector along here, and the vector along here, and then we can perform a cross product, which will find the vector that is perpendicular to both. That's nice and simple enough. I'm going to have to look up how to do a cross product because hell if I can remember, to be honest. But the bit that gets a bit more complex is the edges. So the reason this gets complicated is if you kind of like imagine that we've got kind of like a sort of like a pyramid like this, right? And you've got one face kind of like, you know, normals that way, and you've got one face, normals that way. You've got this edge along here. Now, we've got kind of like a normal that way, and we basically want to get a normal going that way, right? Because basically the line you have to cross to kind of like cross this line to the next triangle. So, you know, we can take this sort of vector here and we can cross product it with this one to get one pointing that way, but that's only half the story, because then what you end up with is you end up with kind of like a split normal, right? Looking from the side on, you end up with kind of like this, where it's kind of easier to cross into one way than, it, you know, if you were to say, like, take this kind of path to here, you cross over, and you actually have to come back. Oh, no, hang on, it's not that. It's that in this entire space here, it's ambiguous which triangle you are currently on top of, because if you're here, you've crossed this boundary, so now you're in this triangle, but then, you know, instantaneously you've crossed this boundary, so you're in this triangle. So what we actually want to do is, when we're actually, you know, taking this normal here, and we're taking this normal, we actually want to average these two normals together so that the split kind of is the same on both edges. You know, so both sides of the split have exactly negated normals. And it's going to be easiest to do that if the normals are kind of pre-calculated. So I'm going to allocate some memory, calculate the normals. We're going to use them to, yeah, we're going to use them anyway. Oh, I might also do a nice lookup of the... Yeah, I tell you what else I'm going to do. I'm going to flatten the list of triangles into... Does my tracking only break when I've got Visual Studio Code open? Because like it's working right now, and I open Visual Studio Code and it freezes. Man, isn't software just mystifying and terrible all at the same time? Why do we write this garbage as a species, man? Nothing works. Okay, so so we're going to allocate some memories. Allocate some memories? No. We're going to allocate some memory, and then we're going to walk through all of the you know, I'm trying to decide the best time to do this is, I guess I could do it right here, right now. This is the time at which I could also, you know, yeah, thinking about it, I've got this bit further up where I actually kind of like, you know, do this, I actually do the lookup of the vertices. I could feasibly, trying to think the best time to actually turn the list of indices into a list of coordinates is. I'll do it here. I'll do it in the second pass afterwards. That way we're not kind of like repeatedly allocating. And we're going to need a float, multiply the number of triangles, multiply by 3 because there's 3 vertices per triangle. Yeah, so one of the things is, right, a normal malloc will return null in the event that it fails. Honestly, if any memory allocation ever fails in something like this, then I don't really know what the build process is supposed to do, so it just crashes with the error message you hand in. I think that's way more useful in the general case. And generally speaking, if memory allocation fails, something's gone seriously wrong and you might as well just crash the whole application. Especially on a, like a modern system with like virtual memory and gigabytes of RAM, building like DOS style games. Just gotta look this up. Visual Studio Code, like tracking's working right now. It's VC face. No idea. It's probably just that Visual Studio Code is a modern application, therefore it's horrendously heavy on resources. I just gotta tell it like it is. Oh, actually, I'm already looping over the triangles here, so I'll just do it right here. Yeah, that's a good idea. I'll just do it right here. Makes way more sense. And then I think we've got like we've got a global variable with the vertices in it because they can actually bleed across meshes, which is kind of annoying. So the next thing we need to do is, after doing all that, this is, there's like I've got a comment here to check for the degenerate triangles. We can do that right now because we have the information we need. Might be a better way of doing this, but I don't know what it is. Probably not though, right? And I'm writing triple equals because I've been writing in inferior languages all day. Navigation mesh triangle is degenerate. Okay. I like structuring things into like else blocks as well, just because it's... Actually, maybe not in this case. That's just a lot of code to put in an else block. Okay, so then we're going to write back to our list of coordinates here. We can also calculate the normal while we're here. We won't quite be able to... Oh, actually, hang on. We'll have the neighbor information as well, so we'll be able to... but there's no guarantee the neighbor will have had their normal calculated by now, but we can actually get quite a long way here. That needs to be 9, not 3, because there are 3 vertices and 3 axes per vertex, yeah. Okay. So now we can file these away into here. I need to remember to free all these. I'm just going to do that in a sec. Hang on, what's actually in here? I think it's actually, I need to multiply this by 3, don't I? Right, okay, yeah. This is kind of annoying. There's a lot of variables. Yeah, I'm really quite surprised by the fact that VC Face is kind of lagging out. It's also like, it's not like it's dropping frames, it's just not tracking, which is weird. I'm almost sort of curious to know what could possibly be causing that. You know, what resource contention could possibly be causing drop frames and something like that? I wonder if I can do something evil in here, like increase its priority and see if that stops it messing around. Nope, it's still garbage. Good to know. Thank you, Windows. I'm going to blame Windows. Why not? And then we're going to take all of these and we're going to put them all in a nice tasty array. These are all going to be plus something. And it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay. And all these, it's way more complex than just comparing the individual axes, isn't it? Okay. Let's go make sure that I've definitely freed all these up because I will probably forget otherwise. There we go. So yeah, we actually need to compare all 3 axes now, which is annoying, but we'll get over it. Hang on. I need to edit these. How do I need to edit them? This is AB, and then we do BC. Okay. And then we're comparing C to A. Okay, right. Oh, and then Visual Studio just turned that into a single line. Okay. Who needs to be able to read the code anyway, right? Anyway, so now we need to actually calculate our up vector. So our surface normal, as it were. So we need to get the delta along. Yeah, we need to get the delta along. Hang on. Yeah, this is as simple as it sounds, honestly. It's just getting the difference between the A and B coordinate on all 3 axes. This is where a vector math library would come in handy, probably. Probably. Okay, so we then need to calculate the magnitude of these and then divide by the magnitude to get our edge normals. So that is square root of, now we can use the math library here because we are not inside WASM, so we have the math library here. Wouldn't be able to do this from inside WASM. That is going to pose a problem that comes to things like distance calculations, but again, we'll get over it. And then we just need to do the same for AC. This is usually where the last line effect comes in, and I forget to make a change on the last line. That's normally how it works. Last line effect, by the way, is one of the most common classes of one of the most common classes of error, which is where like usually you get to the last line and you're already thinking about something else and you forget to update something you're copy pasting. Now, watch me make that exact mistake right here. Just because you're aware of something doesn't mean that you're not going to do it. I didn't put types on any of these. Oops. Okay. I don't know if you actually have to normalize these. I don't think you do. So a very good question would be, why am I normalizing them? I don't remember. Cargo cruelty is dangerous. So next up, we need a cross product. And a good old place to get that kind of thing always used to be, because I don't remember the exact sequence of operations to do a cross product, but you can find it in here. Yeah, if you're after a very simple kind of like building block style algorithm or something, you'll find it here. So it's just this combination here. I can never remember this. Okay, so I'm just gonna copy this in and then translate. What? Is there a license on this? I don't see one. I mean, I guess something like this is kind of like, you know, common enough that people don't think to license it. So if it's a 0, we want X. If it's a, let's just get all the other ones first. If it's a 1, we want Y. And if it's a 2, we want Z or Z. And then if we want A, that's actually AB. Oh, hang on. And it's not a normal yet, so we'll drop that out. So if it's a B, that's a AB. And if it's a C, that's a AC. Now, there's a good chance this will end up being upside down. But we're going to normalize this first. So we're going to, again, calculate the magnitude and then divide by the magnitude. This is terrible code, but who really cares? None of this really matters. I've just spotted some last line effect. See that? See that right there? See what just happened? I knew it was going to get me in the end. Okay, so now that we've done matrix math, I think we should probably put this, I think we've got like a, I did allocate, I think, yes I did. So now we can put this away into here. And that should do us nicely. So our next step is that we need to, we then need to iterate over the triangles again. And when we do it this time, we need to, this is where we're going to calculate the edge normals. We still need to do it even for ones that don't have neighbors. Hopefully, after this, we can start getting it visualized in Engine, and we'll start to get a bit more of an idea of what we're doing. You know, we can start to validate that all these normals are correct. So, yeah, allocate some more memory. What did I call this in here? Edge normals. And that should actually be 3 times 3 because it's, yeah, it's 3 axes, 3 normals. midpoint over average, I think, because that implies it's been renormalized. Okay, we're getting there. That's good, that's good, that's good. One of the really kind of nice things about this this approach to doing kind of like, well, two very nice things about this approach to doing kind of like level geometry. Number one is that rather than defining where players can't go, you're defining where they can go, meaning that in theory it's impossible to leave the map unless you're supposed to. Number two is that you only have to compute the triangle that you're currently inside. You don't have to give any mind whatsoever to triangles that you're not currently inside. Wait, I think I've just realized what the actual tracking problem is. 1 second. Let's go try something as an experiment. I don't think it's actually a computer issue at all. I think it's a lighting issue. Visual Studio Code is... Oh my god, is this seriously going to make me accept terms of light, use turn some lights on? Because... Okay, how's that tracking now? Hey, it's good again. Right, okay, yeah. That is actually kind of funny. So yeah. After all the talk of it being, going like, oh, this code's garbage. Yeah. So what it was is, this obviously is a bright white window. So it's lighting up my face, so the tracking works on it. And again, this is a bright white window, so the tracking works. This is a dark window, so it couldn't see me. No. Okay. Okay, let's calculate these edge normals. So we need 9. And let's also get rid of them here. And then what we need to do next is... What do we need to do next? We need to iterate over the triangles and then see who the neighbors are. Easy peasy. Oh, actually, yeah, we still need to iterate over the triangles, but we can probably do the edges generically. I think. Not quite, not quite. Okay, so we can actually pull these back out of the array. And we're going to combine these two kind of like sets of lines together. So we're basically going to steal all of this up here, and then we're going to stick it on the beginning of these. And then done. And it's now got first triangle index, so we're only comparing one triangle at a time. And then we're going to pull these out of an array rather than calculating them. It's probably actually more expensive to do the memory hit to pull these out of the array, but who cares? I sure don't. Right, so we also need to pull the triangle neighbors out. And then we can get rid of these. Right, okay. Oh, I actually need to define a type for these. Okay, so first we're going to calculate AB. So again, we need to calculate the normal along AB. Just mean a bit of yeah, recalculation. It's annoying, but could be worse, I suppose. Let's get rid of all mention of first triangles here. Do something similar. We're going to go for all BC. Yeah, so we're just getting the normal vector along here. I really should refactor this. I really can't be bothered. And so we're going to go for CA. Yeah, which is, yeah, it took me a moment that it's AC, not CA, even though it is actually, yeah, just ignore me. I'm just having a brain meltdown here. Okay, that should get us our 3 normals, and then each one of these we then, we need to check what the neighboring is. So if we don't have a neighbor, we just do a cross product, and that's the end of it, really. Now, most of the logic actually is the same. We're only really, the only thing really changing is where the kind of surface normal is coming from. So if it's -1, we are going to basically just copy our, so if we don't have a neighbor along that axis, we are basically just going to steal the triangle's own surface normal. And what else are we going to do? Yeah, otherwise we need to go look at what the neighboring triangle is. Actually, I'm tempted to do that and then just add to it and then renormalize if it's, yeah. Now, it is possible that we'll have, say, it's unlikely. It's possible we'll actually have 2 triangles that are completely back to back. So, say, they wouldn't actually be separate here, it's just for the kind of sake of argument. So, you've got like normal here, and you've got normal here. I don't think I would ever rationally do this. In which case, the average of these 2 normals would actually be just a dot. It wouldn't actually be anything with any kind of direction. So I might just detect that and just make it use, like the kind of like, side normal. Yeah, that's what I'm going to do. So we need to calculate the magnitude of that. And then check whether it's 0, because if it is, we just need to actually get the surface normal out, don't we? Yeah. This code is jank and I love it. Okay, so now we need to check that this is 0. If it is, I should probably be using like an epsilon or something. If it is, I'm just going to reset it back to where it was. Just to handle that case of there being 2 back-to-back faces. Actually. No, actually, what? So I'm just having a good think about this. Because in that case, you actually want the up normal to be kind of like completely perpendicular to both of these and this. So it would actually be Hang on, no, you'd actually want it going that way. Hang on, let's just draw this again. So kind of like, yeah, so like for an ordinary triangle, right? You'd have like your surface normal kind of there. And you'd have your edge kind of normal, kind of like facing away from the camera here. And that means that you want the plane actually going that way. But if you were to say, do that, you'd want it to be going kind of that way. But if these were completely back to back, you'd actually want it going that way. Okay, so yeah, it actually wants to be the other triangle's normal, I guess. Yeah. That's kind of weird. That's kind of weird, but it looks right in the drawing. It's an edge case we're probably never going to encounter. Man, this code is pretty scuffed, isn't it? Okay, let's put this away now. So it's going to be triangle index 9. And let's do a whole bunch of copy pasting. Who's up for copy pasting? I sure am. So every instance of AB needs to become BC in here. It's otherwise going to be very similar, I think. This gives us an opportunity to kind of review and make sure that's still the case. Looks like it. Oh. What? What just happened? I really need to get that fighting game readout put in at some point so I can see what the heck happened and look at a VOD. Now there is a difference here because this needs to be 3, 4, 5, and this needs to be redefined. And we've got one more loop, which is going to be CA rather than BC. And again, we just need to bump these indices up slightly. I didn't actually define these. That would have been a good idea. The compiler will probably have a good time with that. Oh, we didn't actually do our cross products. That was stupid of me, wasn't it? Where's our other cross products implementation? Let's rip that out. Where is it? There it is. There's our cross. I need to normalize it again. Damn, it's a lot of copy paste. I really should have refactored this before I wrote it. Okay, so we have our AB normal and we have our AB surface normal. Okay, so now we just need to do the cross product and magnetize it? No, we don't need to magnetize it. So, this is going to be a second one, isn't it? So, I nearly screwed that up. I nearly put the wrong axis in. Now that would have been like, that would have been chasing around it for hours if I'd done that. Okay, and then I'm just going to calculate the magnitude of that, same way we always have. Still should be putting this in a refactor function. Don't really know where I'm not. Guess I just don't care anymore. And then we're going to calculate the final product. And then we're going to swap these over to these. This is some terrible code, but once it's written, I probably don't need to ever look at this again, so I don't really care. And again, every instance of AB needs to become BC. Nice and quick, nice and quick, nice and quick, nice and quick. Just looking at all these, just giving a quick scan with the eyes just before I overwrite them forever. And don't forget to update those, you complete idiot. And then BC to CA. Sounds like I'm playing some particularly boring game of chess, doesn't it? And don't forget to increment the indices. Okay, now I think we can actually export this information. So we're going to loop over the triangles once again. And I guess this is where we're going to do a big chunky looking right. So we're going to have let's send this again, so it's vertex location. So that's going to be, it's going to be 3 floats. Oh yeah, we also need to wrap the whole thing in an object. So 3 floats representing the location, and then 3 floats representing the surface normal. They're not integers as much as you want them to be. And then 3 sets of 3 for the edge normals. So that's 1, 2, 3, 1, 2, 3. Oh my god, 1, 2, 3. And then one more, just close it off. And then we actually need to provide all the arguments to this. So there's going to be quite a few here. Okay, so first of all, we've got the location, which is going to be vertex locations, triangle index. And we've got 3 per triangle, so we'll do that. The compiler will probably go to town with this and do some kind of wild, kind of like rip through memory or something. I don't know. It's smarter than I am. And then we've got the normal, which again, we can do almost the exact same thing, but we're going to replace locations with normals. And then we are going to do almost the exact same thing. We're going to multiply by 9, and it's going to be for the edge normals. And we're going to supply a lot more than 3. Okay, let's see what happens when we build this. It will probably not end well for us. Go on, go on. Let's get rid of this PNG. I don't remember why this is here. It seems to be having a think about it. It hasn't crashed yet. That bodes pretty well, honestly. Oh, do I not have us? Oh, wait. I actually need to include the math header, don't I? Okay, we've got one more error here. What's this? What doesn't it like about this? Oh, I guess I copied and pasted that for a reason that is completely escaping me. And then we've got something unused here. That implies I've done something wrong. Yes, these should be the normal that we're reading from. Again, I don't know if it actually makes any difference for a cross product. I don't remember if it does. Oh, we got some not and numbers. That's tasty. That probably means we're not initializing some memory, probably. Let's have a look what we got here. So the location looks pretty plausible. The surface normal looks pretty plausible. And then we have plausible, plausible, implausible. So what's special about these up here? Well, I was hoping I'd be able to correlate it with the whether they had a neighbor or not, but it looks like that's not going to be the case. Let's just see what it looks like when we kind of split it out. Like, is there a repeating pattern amongst the triangles? Not really. It looks like first, second, first. Okay, there's no obvious repeating pattern there. Let's have a quick check over the code that actually puts this into the array, because that's the most likely place I'm going to screw this up. I don't think it's going to be a copy and paste issue, given it seems to be affecting basically random parts of the, well, random normals. By the way, it's just written the literal non as well. That's actually it's kind of funny. Okay, let's see if we can figure out which triangles these actually are, because we have the locations at -1, -1, 0.24, and then 2.3. Okay, yeah, that's the first coordinate. Oh wait, I'm actually only exporting the first. Yeah, it's actually going to be 9 things we need to export, not 3. This actually needs to be 3 times 3 because we've got three vertices and 3 axes. So let's go back into the code that actually generates the code. That was easy to find. That was easy to find, wasn't it? And we best need to take this here and just replicate it here. And replicate this here. And see what that does when we build it. Probably something equally broken. That's what we're here for, though. Taking a while to build, isn't it? I wonder why editing this is having an effect on... It seems to be recompiling textures, which doesn't make a lot of sense given we've only edited code to do with models. Maybe just didn't hold on to something for some reason. Oh, okay. Let's have a look at our individual triangles here and see what we can figure out what's going wrong. So where's the other bracket? There it is. So let's see here. That's interesting. 2 of the coordinates of this triangle appear to be in the same place. -1, but not 2. Then one of them isn't. How's that possible? Doesn't quite add up, does it? Is there a bug with our triangulation code? That's definitely possible. Or are we maybe grabbing the same triangle out twice? Sorry, the same vertex out twice. That's also possible. Ah, hang on. This needs to be multiplied by 9, not 3. That's probably at least part of our issue. Let me just check other places using this. Yeah, that's part of our issue. Let's give that another go. That looks promising. I don't mean to alarm you, but that does look promising. Okay, so let me just fix the code it generated, and okay, so our next step is we need to add a component to be able to add a nav mesh to the scene. So I am actually going to, where are we going to steal this from? Let's go to the opaque mesh component because that's already kind of, actually no, it's not quite the same because it's got a selectable thing in it. Whatever, I'll grab it anyway. And we can get rid of all the stuff about being able to select. Now, we're not going to be actually rendering it, so I'm going to call it hosting. And we'll go for only 4 of them by default, because most of the time you're going to have basically like a single kind of base mesh, and then maybe like a couple for like elevators or something. That'll do. Don't need any of the stuff to do with selectable components, none of it's relevant. Don't need any of this, none of this is relevant at all. And I'm going to make it so you can't replace them because that would break a lot of things if you could. I'm thinking if you want to replace it, you should just delete the component and recreate it. Should I have built meshes like that in the first place? Ah, no, because they've got selectable state. Yeah. Not selectable, so we can get rid of that. Okay, we're getting there, we're getting there. Now, I am probably going to add a kind of like a debugging tool that, say, draws a wireframe of each nav mesh with the normals displayed, just so we can see what the heck we're doing. Because I'm not going to be able to tell really whether this is working or not. Well, I can need the camera, not at the moment anyway. The video buffer. Oh, this still uses the index pool. Oh, I should really get rid of that before I continue. Okay, I'm going to get rid of that before I continue. I think this might be the last place it uses the index pool, so I can get rid of that from here. And let me just verify that. Oh, it's still using the base entity, but we're going to get rid of it from one place after another. Yeah, get out of here. So the reason for that is, I did this when I was very, very ill. I had this idea that, hey, I have a lot of cases where I have a sequence of things that all need to, I need like a way to quickly delete them. I need a quick way to like make a dense list of them. I know what, I'll make like a reusable thing. And then I realized what I just basically made was a list of pointers, but worse. So I've decided against that. Yeah, so this should be nice and straightforward. So all I really need to do is just search for the array until I find an empty slot. I think I had a thing in here where I said I was going to, just a note of an optimization we can do for the future is to basically like remember the last place we left an empty slot. Get rid of this and this and this. Okay, so what we're going to use to indicate that something is not in use. Yeah, we had like this list of indices, which just meant you were doing this nasty indirection stuff, actually quite terrible for performance. I guess I can make it so if the view projection matrix is null, then we know there's nothing in that slot. It's basically like a pointer to the matrix in the parent component. Could probably get rid of that eventually, but for now we're going to use it. And that means that when we destroy one of these, all we need to do is set this to null so that we know we can use it later on. That's nice and simple. That's good. Is that it? Oh yeah, we also need to get rid of this. Yeah, for now we're iterating over the whole thing because we're not keeping any kind of solid record of where the end of the list is, but that's actually kind of fine. It's not a big deal. Okay, that's simple enough. And is there anything else we need to do in here? No, I think that's everything. Let's just make sure the game still boots after I've done that. Oh. Ah, yeah, I need to add an error case in here because when you create at the moment, there's nothing to say. There's nothing to throw an error when you get to the end. If it checks every slot and they're all filled. There we go. That should crash the game nice and hard. Now I have just changed like everything, so this is going to take a moment to build. So let's do a parallel build. Oh, crashed the console again. I cut Visual Studio Code some slack earlier when I realized it wasn't the reason my tracking wasn't working. I'm going to give it some slack back for having a terminal that keeps crashing. Even though I probably am putting it through some paces it was never designed to go through. Ah, look at all this text, isn't it delicious? Okay, the game still seems to work. I might actually just reboot it and just make sure that, like creating and destroying objects works properly after I've made that change. Storage, local storage, delete. Do I close the inspector? Oh, there's a cross in the corner. That'll do, won't it? Oh, I should totally fix that one frame flash at some point. So yeah, that was a lot more painful to write the first time around. I'm surprised how quickly I managed to get that to work. So, oh, hang on, I was halfway through committing something else, wasn't I? Like me to have to have a scatterbrained approach to everything, is it? Okay, that's good. And so I'm basically going to take this approach and I'm going to paste it to here. And get rid of everything to do with setting selectable, everything to do with layering, setting meshes. Get rid of all the stuff about selectables. All of it can just go. Don't need that, don't need that. Can use this for the navigation mesh. Maybe you should have like an assets directory for things like textures and meshes. Yeah, that probably makes sense, wouldn't it? Right, so what's kind of next? Probably get rid of the matrices, right? Okay, I'll keep it. I'm not going to have that many of them. Now we're going to run this, and either things are going to be the right way around, which is a miracle, never happens. You always have to flip things around at least once. Or things will be in all sorts of random directions. And that's when I'll just go, and leave it for another time. Don't do any of that. Oh, almost there. Okay. And then this needs to be a navigation mesh. Okay, that's good. Yeah. Oh yeah. I forgot. Yeah, I'm no longer doing the underscore T suffixes, am I? Let's get rid of those at some point. Okay. That looks good. That looks good. That looks good. Next up, I'm going to put a function here to just visualize one. And this is also going to have a model view matrix. Yeah, let's put a matrix in there so we can pass whatever in. I should probably also pass in the matrix I'm actually rendering, shouldn't I? That'd be a good idea. Okay, that's good. That'll do. I don't actually have a C file for this, do I? I do now. You know what? I'm actually running over time. I need to stop before I fatigue myself to death. So thank you very much for watching. And I'll see you tomorrow. We'll hopefully get these things on the screen and figure out if what we did today actually worked. Have a great evening.